quite a volume of lab reports and so forth. I'll be grading those and getting a grade posted.
Yeah, that was really good. So,
Later today or tonight, one or the other, but most of those look pretty good. I did comment to Tyler here that sometimes if you happen to put something in on Notepad, it does not carry through and it's not printable. So if you can, make sure it's a Word document. Most everybody did a Word document, so it worked out fine. And most of them look pretty. Yes, please.
This is Carolyn. Did you get my my lab assignment?
I think so. I got a stack here of about I don't know, looks like 50 pages of stuff. So I'll review it and as far as I think I got yours, Carolyn. I'm pretty sure I did. I remember the note that you sent. So it's been kind of a hectic weekend for me. We cut grapes in the rain on Friday, and I've had to deliver part of those on Saturday morning, and then I've hauled produce every day since. So been cutting grapes again today. So it's the fall is usually a hectic time in our world. So most of have any connected to agriculture in any way, you understand we're in the midst of a harvest season, so it makes it kind of tough. So. But we will continue.
I realized where I messed up.
Don't worry about it. We'll do.
can y'all hear Keysville?
I actually sent you the notepad thing. I didn't see
We hear you, Anthony. Thank you.
it.
All right.
Sorry about that. They got Keysville working now.
That's fine. I thought I saw the
back end. Yes. Okay.
Okay, we're gonna try to pick up sort of where we left off last week on chapter 2, beginning to talk about biomes a little bit and some of the factors that affect or create the differences in biomes. And one of the first terms that we talk about, and it's one that you need to understand the definition of, because it's quite a key component. The term I'm talking about is the word climate. And what's the difference in what we're talking about climate? What's the difference in climate and weather? Anybody?
Whether the pattern of, the weather and climate determines the overall setting of the biome.
My question was, what's the difference in weather and climate?
Climate is what you expect, weather is what you get.
That's close. Climate is over a longer period of time, where weather is a spot or a survey of the conditions that exist now, or what is going to be predicted for tonight or tomorrow. Today, the weather is warm and sunny in our area. Tonight, the weather is supposed to be stormy and it's supposed to be rainy, drizzly tomorrow. The climate that we're talking about right now, we're in a period of change as we move from one season to another, and the climate is more of an annual or a yearly type of event, and the climate varies within locations. When we're talking about climate, theoretically, Southside, Patrick Henry, and Southwest are in the same latitude, but we have minute differences in climate because of that. Those differences are brought about by the differences in, we're basically on the same latitude, but we have differences in height above sea level.
So basically weather is the short term and then climate is long term?
Right. Weather short term, climate's long term.
Okay.
But as we talk about the weather or the climate, as we compare Southside, Patrick Henry, and Southwest, there are distinct differences. that are brought about by the height above sea level. South side, down where Tom and the folks are in Alberta, you're at what, 600 to 700 feet above sea level?
I'm really not sure.
Okay.
I call it.
Well, I think that's the range. We've had that discussion. We have it every year, but I remember that as being, it was somewhere between 600 and 800 feet above sea level. Where we're sitting here at Patrick Henry, we're about 1,000 feet above sea level. And at my home, I'm at 1175.
Does it result in cooler temperatures?
We're working there. And where I sit at my house, I can look to the northwest and see the crest of the Blue Ridge, which is at 3,000 feet. And in southwest, I think that the college is at about 2,500 or 2,600 feet, and where Dwayne used to live, Dwayne lives, was at about 3,300 feet. So as we talk about the differences in this elevation, as Tyler just mentioned, those differences create temperature differences, which are a component of the long-term climate. In the course of the winter, we'll get some more ice and snow here than they normally do at Southside. And where Dwayne lived at Southwest, he would get snow on a regular basis where we would get rain because of that difference in the height above sea level. So, that for every 1,000 feet change in elevation, it's thought that there's about a 10-degree difference in the average temperature.
So 1 degree for every 100 feet?
That's a breakdown, yeah, roughly. Quite often, from my house to the crest of the Blue Ridge, there's about a 10-degree difference. And that's one of the reasons that we have problems in our county with the scheduling of school. That 10-degree difference between the crest of the mountain will cause it to be icy or snowy up there. We're on a total county school system. The high school serves one school serves the entire county. So in a given day or week during the winter, it's not uncommon for them to miss a day or two because of ice or snow or precipitation. Quite often, they'll have fog that freezes on the trees in the road up there, which is an extremely hazardous situation just because of that temperature difference.
Did you think freezing fog?
Freezing fog is one of the most dangerous things you'll ever see.
I have never even heard about it until this point.
Well, you're familiar with a foggy day, and on that elevation, they get a lot of, they're actually in the clouds. So that elevation, those cloudy situations, when the temperature drops down to the range of 30, those little ice particles out of those clouds will freeze on the road, the trees, and everything, and it's a very hazardous situation for travel.
So basically anything that's within the fog cloud freezes.
Pretty much when it's that cold. And you're 1,000 feet higher than what we are, so it's an issue.
That sounds utterly horrifying, even if I was on foot.
It can be. It can be pretty terrifying. But, that's what we're talking about with the differences in climate and weather as we move along. So, those are questions that quite often appear on tests. So, we talk a little bit about biomes and climate and microclimate. The term microclimate comes up, and what would be a definition of microclimate?
Climate from like a town instead of like a state.
Try that again. I couldn't hear you very well.
Would it be something like climate for a town instead of like the climate for a state?
That could be, but when we're talking about the areas of plant production, generally we think of a microclimate as even smaller than that. The climate in my grapevines at home, for example, on the exterior of the vine, you're gonna have a certain temperature and a certain level of humidity that is greatly different than it is within the canopy of that grapevine. Or if instead of a grapevine, let's think about a large maple tree that you've got in your yard. The climate outside of that maple tree in the yard the temperature's gonna be one thing, the humidity's gonna be another. And if you move up under that tree, you're gonna have a totally different scenario. The temperature in the shade underneath that tree is a component of the microclimate. In other words, it's a small area. So the temperature may be 80 degrees out in the sun, and it may only be 70 up underneath the shade of that tree. Humidity out in the sun may be 40%, but the humidity, when we take it underneath the shade of that tree, may be 60%. So as we talk about microclimate, there are quite tremendous variations in the factors that make up the weather, the temperature and humidity and things like that. The wind may be blowing or moving on the exterior portion of that tree, but when you get up underneath the tree, you're in that canopy, and it's protected. You may not have the air movement. So, as we harvesting grapes now, as you guys know, so, we've been dealing with this microclimate within the vines that we talk about. We've been doing that all summer. We've been adjusting the canopy to make it more sun getting into the center of the vine, to put sun on the grapes to improve the quality. And by thinning out this canopy, it reduces the shading and the level of humidity there, which will, in theory, reduce our disease incidence. So when we're talking about climate versus microclimate, it's, climate or the weather outside might be more appropriate to use micro weather, but because we're talking about conditions that are existing at a given time. So when we talk about microclimate, that's what we're talking about.
What did you mean by reducing the humidity, you reduce the disease chances? What is that?
All right. Tyler's question was, by reducing the humidity, what effect it would have on the disease incidence. Most diseases are pathogens that like moisture or humid conditions. So we're primarily concerned with mildew, and powdery mildew, downy mildew, and botrytis. That's an infection that occurs on grapes. So by reducing the canopy, letting the air move through, it changes that level of humidity, and the conditions are not as conducive for the incidence of those diseases.
So by reducing the water content on the grapes, that doesn't give it as much of a breeding ground?
You used a different term. You used water content. We're talking about humidity.
I was just in general?
We're talking about humidity, so that means it's more humid in that canopy. It's not really water, it's just
the humidity in the air.
Moisture in the air.
Okay.
And it doesn't allow that vine or the grape or conditions to dry out as well. So once we get dry conditions, we have fewer disease problems. And this is true with any plant we're talking about. I'm talking about grapes right now, but if you're growing squash or tomatoes, that's when you run into problems with disease. When your canopy or your vines get large and heavy, they don't dry out. This morning, when you left home, most of you, I would think, when you left, you had to turn the windshield wipers on your vehicle if it was left outside, because of the condensation that occurred. And that condensation occurred when the temperature reached the dew point last night. And I'm a little bit off topic, but these are things we need to be aware of. What's a dew point? Anybody know what a dew point is?
Isn't it kind of like when the moisture level in the air reaches to the point where it'll the condensation will go on anything outside.
Yep.
Saturation.
You're exactly right, but the dew point is a temperature. And it is the temperature at which time your relative humidity reaches 100%. And as we talk about climatic conditions, dew point is a critical thing, and it refers to the amount of moisture that's in the air. And as we move from the point in the year where we are right now into the winter, if you're observant with the dew point, if you're watching weather forecast, say temperature now is 60 degrees, but the dew point is 40, that will, if you are aware of it, that will tell you that the dew point is the point at which the relative humidity reaches 100%. So that is the bottom level to which the temperature will fall on a given evening.
So dew point is the floor for the temperature.
Pretty much. And it changes with the humidity level. So, but it's dew point is an interesting thing. But last night the dew point we reached 100%. Dew point may have been roughly 57 or 58 at my house, but the entire atmosphere, surface areas, were covered with moisture. So we reached 100%. All right, as we talk about biomes, climate, and microclimate, all of these things are affected by air movement. And the air generally moves at one direction at ground level and the opposite direction in the upper atmosphere. And it creates certain areas of shift in the air patterns, and that creates differences between the equator and each one of the poles, the North Pole and the South Pole. It creates bands of air that move. And these bands or levels of air are controlling factors to our weather. We're facing another tropical storm in the next week to 10 days, and it's going to be controlled or determined where that thing tracks based on upper air currents. Initially, when this storm first started off the coast of Africa, it was thought that it might come out into the Atlantic and then veer more north. And from what little I've been able to observe in the last day or so, it's being forced to travel almost due west from where it originated. And this is controlled by a huge high pressure system that's located over the central portion of the Atlantic. And it's keeping it forced down. I think it's now scheduled to come across in the area of Cuba right now. And then it's in about 4 days, it's supposed to get to about the point of Florida.
And they were saying that there's a possibility if it actually escalates to a Category 5.
It already is a 5.
Oh, it already is?
It's more than 175 mile an hour winds.
Oh boy. Well, they were saying last night they were saying if it did reach that point, there was a fairly good chance. I think they said it was like 56% chance they could actually head up as far north as the Carolinas.
Yeah, they don't know right now where it's going to go, and it depends on the movement of that high pressure system that's out over the Atlantic as long as that blocking high, and that's the term they're using for it, it's blocking the movement of that thing to turn north. They don't know, as long as that high stays in place, it's going to have a controlling factor over this storm. I'm a little afraid that we may be in for a pretty heavy rainfall out of this one. And I'm hopeful we don't get the winds, but we're dealing with roughly 350 mile range between our service areas, between southeast and southwest, with Patrick Henry being in the center of it. So some of us are going to have some negative effects of this storm, I'm afraid. So But as we talk about these winds, this high pressure system is nothing more than a circulation of wind that we're talking about, and it's having a controlling factor on this storm. The normal trade winds, or winds that exist on a day-to-day basis, carry moisture from the oceans across a given region, and the elevation of the air causes it to cool, and usually drops a fair level of moisture. In an average season, we tend to be a little bit drier where we are because of the mountain range that's just to the west of us. There'll be warm or moist air coming out of the Midwest, Mississippi River Valley, and if it's not a huge system, storm system, it will drop a lot of the moisture on the west side of the mountains. And this creates in effect a biome in itself, because of that moisture-laden air increases the rainfall in that area. And this is one of the reasons that grasses are so productive in that area around the Southwest, because they can, even though it's mountainous, the cleared land that they have with the rain that they normally get produces a real lush vegetation that they use to harvest for hay and crops of that type. Their land is not very well suited to major production of corn, soybeans, and things of that type, like it is down in the south side. So, we'll get, in the middle of the summer, in our particular area around Patrick Henry, we'll get normally the majority of our rain comes from thunderstorms, and as all of you know, they're sporadic. It may rain here and not rain on the other side of the strait. So, the winds determine where this moisture is picked up, and where it is deposited. Sometimes the jet stream. How many of you know what the jet stream is? I'm not talking about that vapor trail that you see in the sky.
Is that jet stream the really fast moving current between low and high pressure zones?
Pretty much. Jet stream, it may not be between low and high pressure zones, but jet stream is a river of air that travels around the world, and it controls our weather because of the way it shifts and moves. So when the jet stream sweeps out of Canada and down low towards the Gulf and back up, we normally get in a pretty stormy regime, because it'll be cold air coming from the north down, it'll pick up warm, moist air, and it'll sweep up the Atlantic coast, and it'll drop that moisture on the eastern seaboard because of it. Jet stream determines our hot weather, our cold weather, determines all of this stuff. So the weather, climatic conditions are something I've always enjoyed and love to watch. So being a weather forecaster, I think I may have missed my calling, because I really do enjoy that stuff. Water and temperature are key factors in the growth of plants. They determine what grows where. Tropical rainforests are one of the most productive biomes that exist on Earth. And what do I mean when I say a tropical rainforest?
An area with a constant high humidity and a lot of annual rainfall.
Yeah. And it is a major user of carbon dioxide. There's been a lot of harvesting of the tropical rainforest for the timber. And scientists say that has had a dramatic effect on the CO2 levels in the entire world, because the trees and that vegetation in the tropics, see, they're not affected by seasons. It's always warm and muggy there, and plants are constantly growing. Where in our area, we're going into the fall, and soon our deciduous plants are going to drop their leaves and we will not be using carbon dioxide. The term deciduous, did everybody understand what I mean by deciduous plants? Deciduous? All right, deciduous, a deciduous tree, something like an oak or a maple. Deciduous means that it drops its leaves and goes into a period of dormancy. The tropics don't have deciduous plants. They have plants that hold their leaves year round. So they're constantly carbon dioxide, where in our area, come about the middle of November, we're going to have leaf fall, or trees are going to drop their leaves, and they'll go essentially dormant. They'll go to sleep because of the temperature. And they will stay that way until normally about the first or second week in April, when they begin another cycle of growth. So that's what we're talking about, the difference between deciduous and evergreens. In tropical regimes with tropical rainforests, there's very little bit of growth in the understory, the portion of the ground underneath the tree. In other words, the trees that are above, because that tree level above is dense and heavy. That's where these trees are growing. So in that area underneath there's very little growth because of low light levels. They don't have any light, so there's nothing underneath there. Not enough to substantially allow plants to grow. If any of you are familiar, even in our area, if you walk through a dense, say an oak or heavy pine woods, there's not much in the way of vegetation on the ground.
Sure.
Now, if a forester comes through and cuts that timber, cuts the trees, whether it be pine or oak, what happens over the next year and a half?
Little things that were dormant in the ground start growing.
Yeah, because of what? The light that was enabled to reach the ground.
Oh, I thought you were going to start talking about the climates.
No. Well, it is a factor of climate, but it's the light level that, once the trees are harvested, it allows the illumination to get to the ground, and then it will begin to reforest. It'll all sorts of things begin to grow.
That would explain this one oddity that I have. I actually live in the forest right in my house, and I have pine trees all around me, and there's this one really weird spot on the back of our property. And everywhere else in the back is thick pine forest, but there's this one area where the canopy is a bit lighter, and there are ferns everywhere, and they stop exactly where the light stops in that circle when it roughly is around noon.
Well, that's an example of what I'm talking about. There's enough light under that particular tree to allow the ferns to grow. That's all. That's. But ferns are not a plant that like real high light levels. They like partial shade. So that's one of the things. Yeah, but that's what it is. And that particular fern that you've got is adapted to those conditions that are.
Literal circle there.
Mm-hmm. That's exactly what that is. I'm skipping over a little bit of stuff. Here it talks about the biomes and so forth. He said about the 30-degree parallel, both north and south of the equator, is a divergence of the global air circulation. Air moves away from these latitudes in the trade winds toward the equator, and then the westerly towards the temperate latitudes. But we have different air movements in that area of the equator. And if we look at the 30th degree north, that runs along right with the southern border of the continental United States, right along the northern edge of Florida catches about half of Texas and a little bit of the California, New Mexico area. And we have a different plant population in that area as compared to the more northern areas. I won't start to go into the deal about degree days, but that'll confuse everybody right now, so we won't talk about that one.
Could difference as small as just 1 or 2 degrees make a drastic change in what plants can grow in any given environment?
You made it'll make I don't know whether you can say drastic change, but it will make a difference in things. 1 or 2 degrees may not, but it depends on whether you're talking about the difference between 30 and 32. That's only 2 degrees difference, but a drastic difference because
one's freezing and then
one's freezing, one's not. So, that, but we rarely are in environmental conditions that 1 or 2 degrees make that much difference.
Okay, so it has to be something greater than.
Yeah.
Okay.
Now, when we go talking about the global environment, when we get to the difference between 40 degrees north and 50 degrees north, that's about where we reside. It says that areas with over 75 centimeters of rainfall, which means about 30 to 35 inches of rainfall, is where the temperate forests occur. That's the area in which we reside. It says there's very little land in these latitudes in the southern hemisphere. So most of the deciduous forests are in the northern portion. But as we talked about a while ago, the deciduous plants are the ones that drop their leaves during the winter. And this annual leaf fall adds to the nutrient levels in the upper layers of the soil. I know my grandma used to always want to go get some woods dirt, was the way she referred. She loved to grow plants and flowers and so forth, but she didn't like her normal garden soil. She had to go get woods dirt because it was higher in organic matter and had a lot of potassium and phosphorus in it, which was conducive to the types of flowers that she wanted to grow. Trees draw a lot of the nitrogen and phosphorus out of this area when these plants lose their leaves. I try to give you some other examples. The area where I've got my vineyard planted was an area that we had apple trees on for probably 60 or 70 years. And with that production, all we would do would be mow the middles of the tree, between the rows of apple trees. It was shaded underneath because of what we were just talking about. The apple canopy would prevent much of the plant growth underneath. But because we mowed this grass that was between there for 50 or 60 years, when we took these apple trees out and we began to do the grape production there, we had a real high level of organic matter in this soil. The organic matter contained a lot of natural nutrients. So as we started thinking about planting the grapes, Virginia Tech told us as we were beginning to do that normally grape production you would be hopeful to get a half a crop the third year of growth. We got enough growth the second year that after we planted the grapes, that we got about a half a crop that second year. And the third year, we got more than the state average yield, just because of all the organic matter and the nutrients that were there. And the organic matter holds a lot of moisture and water and enables plants to grow really, really well. That's why if you've got a garden at home, You like to keep your organic matter levels high. It reduces your need for nutrients and supplemental water. It's a real advantage or an attribute as you begin to grow things. So, as we talk about that situation at home, we planted this first block of vines in 1999, and I didn't put a pound of fertilizer on for 14 years. After that, I began to put a little bit of nutrient added to it, but we've been surviving off the nutrients that was left there.
From the apples?
What?
From the apples?
Yeah, from the apple trees and all the grass that was mowed there. So that's why when I see people taking grass clippings off of their lawn with these lawnmowers with the grass catchers, I think that's, I don't understand it. I don't know why they do it. From a production standpoint, it's not a positive. What you want to do is let that grass clipping go back and provide organic matter and water holding capacity. Save the nutrients that you had rather than carrying them off. That's why also when, folks down in South Side or Southwest are cutting hay, they're harvesting a crop. And once they harvest that crop, they need to go back and fertilize that crop. Some of the poorest hay fields you ever see are fields that people do not fertilize on a yearly basis. Taking the nutrient, the plant material off, you're taking nitrogen, phosphorus, and potash, and all the minor elements that are held in that crop. You're taking it away, and you need to supplement it if you're going to continue to grow hay on a year-to-year basis. If you're grazing cattle, it's a totally different animal because that cow is going to graze the grass, and it's going to go through that animal and then have the manure dropped, and that's going to be organic matter and a lot of the nutrients that were in that grass to start with. That's why one of the common practices now that you'll see is folks riding over their pastures with a chain drag or something to relocate those piles of manure that were there. They're refertilizing their pasture by the redistribution of that organic matter and so on. So that's the soil, the way it is in any of these biomes, the soil is then your bank account. It holds the nutrients and the water holding capacity that you have to produce a crop.
So grass clippings make for good organic material to start growing things in?
Sure. Well, as they degrade or decompose, yes. The term now, people talk about composting stuff, compost this. And that's fine, but all you're doing is salvaging organic matter, whether it be from grass clippings or table waste or
Wood chips.
Wood chips, yeah. Wood chips take a long time to decompose, but grass clippings are fine and small and tender, and they'll decompose pretty rapidly. Some people put their table scraps in, their eggshells. Eggshells are a wonderful source of calcium. They'll put coffee grounds in composting. And composting is nothing more than the beginning or the initial phases of a decomposition to make what we call humus. Humus is a high organic matter compound that is a component of soil.
That would explain a lot because back when I actually still used to gather clippings with my lawnmower and then just dispose of them. There was this one spot on the side of my property where I would always take them and dump them along with the wood chips from my bearded dragons habitat. And I noticed that after about a year of doing this, wildflowers actually started growing out from there when previously it had clearly just been a lot of dirt.
Well, you change that microclimate in that area, as far as the soil is concerned, from a sparse, dry, inorganic situation to an area that was conducive to that wildflower by the addition of that organic matter as it decomposed. It composted. So, a lot of people are making a big deal. And if you're growing a small garden at home, composting is great. And you can buy, commercial products, bagged products that are there. There's a firm called Black Cow that will sell topsoil and manure and composted materials that you can add to your soil. But it's expensive, but yet it is available. And if you're doing it on a small scale, it's a wonderful thing to do. So, any questions about what we've talked about today? I've sort of rambled a little bit going over stuff, but trying to bring it to you in a fashion that you'll understand a little bit more about it and bring it home to you. We're about a minute away from our fire drill that they're going to have, so we'll talk about the differences in deserts and forests and lands and savannas when we get back together on Thursday. But so glance over this stuff. If you got any questions, sort of bank them until Thursday, and we'll try to talk about it then. So, all right.
Okay.
No question?
Y'all got anything? Keysville, y'all happy?
No.
No. Anyway, fire alarm.
Yeah, we're getting our fire alarm.
Okay. Well, bye, have fun.
Thanks.
Yes.
All right.
Fire drill, everyone.
Okay.